Hello students, we continue reviewing trigonometric functions, and this lecture will start with a short example just to motivate ourselves. And in this example we want to do the following: find all six trig functions of theta equal to negative pi over 2. So what we have a circle, and we're moving negative pi over 2. So that means we're going clockwise and we're moving quarter of a circle, so negative pi over 2. So probably it would be good to use unit circle here. R equals to 1, right? R is equal to 1, so this distance will be 1, and so this point is denoted by 0 for x, negative 1 for y, since we went 1 unit down. And sine of theta is y over r, and y is negative 1 over 1, so it's negative 1. Cosine of theta is x over r, our x is 0 over 1, so it's 0. And our tangent of theta is y over x, which is negative 1 over 0, but we cannot divide by 0, so this value does not exist for tangent. And it will be important for us when we plot the graph of tangent. Then cosecant of theta is 1 over negative 1, which is negative 1. Secant of theta is 1 over 0, which we cannot do, so it does not exist. And the last thing is cotangent of theta, which is 0 over negative 1, which is 0. So we did this example just to practice a little bit before we move on to identities. So the next topic is identities. We'll learn some identities, and some of these identities we're going to use, and some we probably will not use, but maybe it's still good to review them. So first set of identities comes directly from the definition. So if you write sine of theta to be y over r, and you will write cosecant of theta to be r over y. You can clearly see that they're reciprocals of each other. The same we can say for cosine, which is x over r, and secant is r over x. For tangent, we can say that tangent of theta is y over x, which implies that cotangent of theta is x over y. So we can create a first set of identities which would be reciprocals, right? So we can say cosecant of theta is equal to 1 over sine. Secant of theta is 1 over cosine, and cotangent of theta is 1 over tangent. That was the first set. Then another thing that comes directly from the definition is, if you think about tangent, which is y over x, what you can do, you can divide, or you can multiply both numerator and denominator by 1 over r. And so in the numerator you get y over r, in the denominator you get x over r, and y over r is sine, and x over r is cosine. So the identity that we get is tangent of theta is sine over cosine. And if you think about cotangent, which is just the reciprocal of tangent, it's just going to be cosine over sine. That comes directly from the definitions. Another interesting thing that comes from a circle is if you take any point x comma y on a circle and the radius is r, we know that r squared is equal to x squared plus y squared. But what you can do, you can divide everything by r squared on both sides. So on the left side, we're going to get 1, and on the right side, we're going to write it like this. So what does it tell us? This is our cosine, and this is our sine. So the identity that we can write is, the identity would be cosine squared of theta plus sine squared of theta is equal to 1. That's one of the main identities that we're going to use. Another thing that we can talk about is that if you take a circle, and think about this point over here as being x comma y, and you take it and you make a mirror image of this point down, and this is your angle theta, if this is the angle theta. But if you take this distance theta, and you go clockwise as negative theta, you will arrive over here with an angle of negative theta. Then the x value for this point would be the same as for this point, so it's going to be x. But the y value would be the same as the y value, but with the minus, so it's going to be negative y. Why do we do this discussion? Why do we have this discussion? Because if you think about sine of negative theta, it's going to be negative y over r. And if you take minus and put it outside and think about what y over r is, it's just sine of theta. So sine of negative theta is negative sine of theta. And such functions that satisfy the property f of negative x is equal to negative f of x are called odd functions. So what kind of odd function we know? We know y equals to x cubed is the odd function. Y equals to x cubed. What's going on with these functions? They are this value here is the same as this value over here. So they're symmetric about this line. Over here. Line of symmetry. Then we can do similar thing for cosine. So we say that cosine of negative theta, what would be cosine for this angle negative theta? Cosine will be x over r. But x over r is just cosine of theta. So what can we say? We can say that the functions that satisfy the property f of negative x is equal to f of x are called even functions. Right, so do we know any even function? We know y equals to x squared is an even function. So it's symmetric about the x equals 0. So they're symmetric about this line. This is a line of symmetry you can see here. All right, so what else can we say? It's interesting to notice that if you think about the units, if you think about circle and you think about points x and y, and you think about this angle as theta, then if we come to this point over here, if we move theta units, but then we go around circle one more time and come back to the same place, sine would be the same and cosine would be the same for this extra one circle around angle. So what does it tell us? It tells us that if you take sine of theta, it would be the same as sine of theta plus 2 pi, or sine of theta minus 2 pi. And the same would be true for cosine. Cosine of theta would be the same as cosine of theta plus 2 pi, or cosine of theta minus 2 pi. But do I have to move only one circle around? No, actually I can move as many times as I want. So in general, we can say that sine of theta is equal to sine of theta plus 2 pi n, where n is 0, 1, 2, ... plus or minus. What does it mean? It means if we rotate, if we don't go any circles around, we just use theta, then n is 0. If n is 1, we move either one circle into the positive direction or minus one circle into the negative direction. And this is going to be true if we move as many times as we want. The same would be true for cosine. You can say that cosine of theta is equal to cosine of theta plus or minus 2 pi n when n is 0, 1, 2, ... Okay, so these rules were easy just to figure out from logic. The next set of rules is a little bit more complicated to figure out from logic, but you can also prove it if you want. So sum and difference formulas. And sum and difference formulas would work like this. If you want to calculate sine of alpha plus beta, it's going to be sine of alpha times cosine of beta plus cosine of alpha times sine of beta. And if you want to calculate sine of alpha minus beta, it's going to be sine of alpha cosine of beta minus cosine of alpha times sine of beta. So for sine, everything's straightforward. Plus and plus matches up. Minus and minus matches up. And here, sine, cosine, sine, cosine. It's easy to remember. Cosine is a little bit more complicated, so let's talk about cosine of alpha plus beta. So cosine of alpha plus beta is cosine of alpha cosine of beta minus sine of alpha sine of beta. And again, this is plus, this is minus, and it's cosine cosine sine. Cosine cosine minus sine sine. So plus and minus for cosine. And if we think about cosine of alpha minus beta, it's going to be cosine of alpha. Oh, here mistake. You should have seen it probably. It should be beta, right? Cosine of beta plus sine of alpha sine of beta. Sine of beta. Making a lot of mistakes today, but sometimes it happens. So sum and difference formulas might be useful. Then from this sum and difference formulas, you can derive double angle formulas. Double angle formulas. So we can say that sine of 2 alpha, basically what you do, you go to the sine of the sum and you change beta by alpha. So you'll get sine of alpha, cosine of alpha, cosine of alpha, sine of alpha. Right, so you get sine of alpha, cosine of alpha plus cosine of alpha, sine of alpha. So you get 2 sine of alpha, cosine of alpha. So we can write the identity sine of 2 alpha is 2 sine of alpha, cosine of alpha. And for cosine, you can use a similar idea. Cosine of 2 alpha will be, so it's a sum formula. So it's cosine minus sine, sine. So we get cosine squared of alpha minus sine squared of alpha. So let's put it down as a formula. Cosine of 2 alpha is equal to cosine squared of alpha minus sine squared of alpha. Unfortunately, it's not the end for this formula. So let's think about our first identity that we covered today, the most important identity, which is cosine squared plus sine squared is equal to 1. What you can do, you can solve, for example, for sine squared. So from here you can say that sine squared of alpha is 1 minus cosine squared of alpha, and you can plug it in over here for sine. So what do you get if you plug in 1 minus sine minus cosine over here? This minus will be for 1, so it's going to get negative 1. And minus for cosine will become a plus. So you'll get 2 cosine squared of alpha minus 1. But it's not the end again. What you can do, you can solve this identity for cosine squared, which is 1 minus sine squared. And you can take it and put it over here for cosine squared. So it's going to be 1 minus, you have negative sine squared and another negative sine squared, so 2 sine squared of alpha with the minus. All right. So, for example, you have a formula which has cosine of 2 alpha, but you don't want to have any cosines in the future, then you can pick this form. Or if you have only cosines in your formulas, then you can choose this form. But if you don't care and you can have both of them, cosine and sine, you can choose the first form. Let's talk a little bit about tangents. Tangent of negative alpha is negative tangent of alpha. It's an odd function. Odd. Why do we know this? Because if you think of tangent as sine of theta over sine of alpha over cosine of alpha, then if you plug in negative 1 instead of alpha, negative alpha, yeah, that sounds great. So what would be the proof for this? Tangent of negative alpha will be sine of negative alpha divided by cosine of negative alpha. And we know sine is odd function, so it's negative sine of alpha, and cosine is even function, so just cosine of alpha. So we get negative sine of alpha over cosine of alpha, which is negative tangent of alpha. That proves its formula. So it's relatively easy to show. And what would be the tangent of 2 alpha? Tangent of 2 alpha would be 2 tangent of alpha over 1 minus tangent squared of alpha. How do you show this? To show this, what would be the short proof? Proof is relatively easy. Again, if you take tangent of 2 alpha and write it as sine of 2 alpha over cosine of 2 alpha, and you put it what it is. So what is sine of 2 alpha? Sine of 2 alpha, it's 2 sine of alpha cosine of alpha. And on the bottom, you can put 1 minus 2 cosine squared of alpha minus sine squared of alpha. Got stuck for a second in my head, but let's fix it. So what we want to get on the bottom, we want to get tangent. So we're going to divide both numerator and denominator by cosine squared. So in the numerator, we're going to get 2 sine of alpha cosine of alpha divided by cosine squared of alpha. And on the bottom, we get cosine squared of alpha divided by cosine squared of alpha minus sine squared of alpha divided by cosine squared of alpha. So we divided numerator and denominator by cosine squared. So now we have to do smart cancellation. This goes away, this goes away. So we get 2 sine over cosine, which is 2 tangent of alpha. This one and this one goes away, so we get 1. And sine squared over cosine squared is tangent squared. So we showed this part for the identity. And probably that's a good place to stop, because in the next lecture we're going to start talking about the graph of sine and cosine and tangent. So I'll see you in the next lecture.